When you open your software program, click on Frame 3D Design. This is where we'll be modeling our spiral staircase. Now, you want to confirm our units of measurements here. Now, click on Tools at the top of your screen and find your preferences at the bottom of the box. So here, you want to make sure that the structure dimension is in meter. Now, if you click on the arrow, you can see that there are 5 units here. Just make sure it's in meter, at least for this particular project. You can leave the rest as they are. Click on OK to close the dialog box. Now, the next thing for us to do now is to define our axis. To do that, click on Axis Definition at the top right corner of your screen. So over here, you can see that there are 3 options. You have Cartesian, cylindrical, and arbitrary. So since we are designing a cylindrical shape object, it's best that we use cylindrical. Now here you have 3 options as well: radial, angle, and Z. The Z gives us the height of the structure. Now if you go to the bottom of the box, you can see that numbering. You can see numbering here. We use all these 1 to 3 alphabets value defined to differentiate different axes in the structure. So now the position for radial here is 0. The number of repeats is 1, and the distance, which is the radius of the circle, is 0.9 meters. So confirm that. To confirm numbering to be 1 to 3, then click Add. Click on Add, then go to Angle. Now the angle, this is where we divide the circle into angular parts. So the initial position of the angle is 0. Then the number of repeats here is number of times you want to divide the circle into. This starts 13, and then the distance between the divisions is 20.8 degree. So now change that numbering to ABC. Now then click on Add, and then click on Z to define the height of the structure. The position is 0. The number of repeats here is 13, and the distance between each division is 0.17. Now make sure you change the numbering system to value or define. Value or define. Click on Add, then click on Apply. Click on Close to close the dialog box. Then click on that home-like icon there to visualize our axis. So as you can see, that is our axis that we'll be working with. Now I'm defining our axis. The next thing to do is to define our member section. So find member section at the right of your screen. Now this new box, click on that white icon. This will define a new section. Now there are a lot of stuffs I can go through here. So for this project, let's work with Tube. Now a database, you want to work with UK sections. So confirm that. Then the family, for the first member, we're using CHS, the circular allo section, and the dimension of that will be 48.3 by 5. So choose that. Then click on color, select anyone you like. But if you want, you can leave it at auto. Now click on Add. For the second member, we'll be working with a square allo section. So click on Family again to find SHSC. Yeah. Now for the dimension of the section, click on section, then find 25 by 25 by 2. Then change the color. So click on Add. That's the second member. For the last member, it's UK section as well, and now it's CHS. Now for the section, let's work with the first one too. So change the color, then click on Add, click on Close. Then that you can see the 3 members have appeared here. Now let's erect our first, the central support of the structure. Now click on Member at the right of your screen. As you can see, there is a as something here, we have member type. This was select between members. You can select column, beam, cable, RC column, RC beam. So select simple member, and then at the section, change that to 48.3 by 5. I see it is 48.3 by 5. Click on beginning, and then find the center point of the structure, and then find the height of the structure. So let's do that. Now let's consider that our central support is where all the pi stairs will be attached for the spiral staircase. The next thing to do now is to divide the central support into 13 nodes. So close that. Now click on node numbers at the bottom of your screen. Yeah, we have 2 nodes here, node 1 and node 2. But we need 13 nodes for the staircase. Now click on that. Select that. Then click on edit at the top of your screen. Click on divide near the bottom of the box. Here you can see that you can divide the member using 4 methods. You can divide into number of parts. You can divide using distance and 2 other method there. So here, let's divide into number of parts. Edit that and write 13. Click on execute. Then close division. So now you see we have 13 nodes here. We can begin to model the stair. Now to model the stair, the pi stairs, click on member. So change the section to CHS 25 by 25 by 2. Now I'll zoom in and I'll rotate to get our initial points. Now start from that node. So yeah, raise it up and then raise it down up to then generate 2 points to the second node in the central support. Now raise down and up. As you can see, we begin the next step from the end of the previous one. So take that to the third node of the central support. There too, fine. So you continue that way until you get to the top. Make sure you zoom in carefully. So yeah, I think this is the last one. Yeah, it is the last one. So finish up. I've closed the member. Now, okay. Click on the home icon to see your parts of the structure. Now, so click on node and to switch off the node. So you can see that it's not done yet. Still have some things to add. Okay. Alright. Now let's add some first sets. Okay. Consider selection. And let's add some support to the structure. So here is where you define a new section. You can click on that new icon to define a new section, but I'm not going there today. I just use the fixed support in the already prepared support there. Okay. Click on that. Apply support there. Apply support there too. This doesn't work. I don't know why. Just don't know. So just check the node number, which is 15. Type it there and click on apply. Close that, so you can see. So click on the home icon. Now we have to add the support for the handrail. To do that, we need to increase the height of the structure. So go back to axis definition and then go to Z. Go to Z. As you can see, the position has been defaulted back to 0. Now we need to start from where we stopped first time. So scroll down and click on 2.21. Number of repeats here is let's use 5, and the distance stays the same, 0.17. so make sure that the numbering is at value. Click on add and then click on apply. Close the axis definition. Now, so as you can see, the height has been increased so that we can conveniently add the support for the handrail. Now zoom in properly to the beginning of the staircase, then click on members. Make sure that you're still working 25 by 25 by 2. I'll start from that, and then we are going up with a distance of 0.66 meter. So that's 0.17 multiplied by 4. And then as you have noticed, we are jumping a step. So just count 4 and then end it there. So you continue to do that until you get to the top. And to get to the top of the staircase. So make sure you are jumping a step. Alright, click on members and change that to CHS 21.3 by 3.2. Then close that. Head on to geometry. Click on objects. So click on arc. Says the handrail is going to be in form of an arc. Now here you can model an arc using 3 methods: center, begin, end, begin, end, middle, begin, middle, end. You know these methods, you need 3 points before you can model an arc. So here, for this particular project, it will be best to use that last one, begin, middle, end. So click on that and then click on create members too. So here, once the arc has been modeled, the section you want to use will be automatically created along the arc. So if you click on that, create members. Now click on the first point, to the second, then to the third. So anyhow, continue that way. Make sure you rotate carefully to see all the 3 points at once. So now that's it's a very easy thing to do. Now we need to model the highest floor of the staircase. As you can see, there's a vacant part here we didn't divide during the axis definition. So we need to divide that into 2. So go back to axis definition and then go to angle. Here you see that the position has been taken back to 0. You need to make sure it's at our last point, 270.4. The number of repeats here is 2. We are divided into 2 parts. So, and the angular, the distance between them, which is in degrees, should be 45. And so that should give us, now make sure your number is in ABC and then click add. So that should give us 360.4, just roughly 360. Then close that. And then here you see that it has been divided into 2 equal parts. So this will make it easy for us to model the arc that should finalize the staircase. Now go to geometry and click on objects, and then click on arc. Just as before, make sure that you are okay with begin, middle, end. Then create members, don't forget that. Then move that to one side. Start from the first point, head on to the second one. That shouldn't, okay, go back, go up. So yeah, then so that should do it. That is fine. So now here, so you can see if you go to the bottom left corner, alright, zoom in to view the parts. I want to view the parts and see. Alright, so if you click on section shape at the bottom left corner, yeah, you see that it makes sense. So that's fine. Then that's that thing. Click on that to add the last member. Click on member. Now I need to add cladding to each step of the staircase so that you can apply a surface load on each step. Now click on geometry and click on the claddings. Then make sure the load distribution is in 2-way. Just for this project now, click on contour. Then begin to join all the points. Now I'm going to stop where you started from. Now rotate carefully to avoid any mistake. Now I'm going to do this for each of the step in the staircase. Was that okay? For each of the step in the staircase. Now we have to add some loads to the structure. Now click on load types at the right side of your screen. So here you can see that if you click on nature, you have some loads, types of loads here: dead, live, snow, wind, and others. So click on dead load and click add. Now the initial dead load, TL1, is the safe width of the structure. That's why the color changes to red. So click on that again. That's the second dead load if there is any powerness loading on the structure. Now the live load, yeah, down to that's the third load that will be on the each step of the staircase. Now close that and then click on load definition. So here you can assign values to the node. Now you can apply load on node, member, or surfaces. So here you are applying load on surfaces. That's the reason for the cladding. Now click on uniform panel load, the first option there, and then here go to the Z-axis, and then want to apply load downward. That's why we're using negative downward. Let's use 7.5. Okay, that's fine. Then click add. Click on apply to and select any of the claddings. So yeah, now right click that so you can do everything at once. Then click on select similar, and then click on select by material. That automatically selects the cladding. Then click apply. So that's fine at once. That makes it faster. as the dead, that's the life load. Now I go to the second dead load. Now it's surface 2, and then change the value to negative 6 points. If you use positive, the load will be axing upward. So click on add, then click. So it's still there. Click apply, and then close that. That is the second dead load. Do not forget the first dead load. You have to apply any value to it. It is the self weight of the structure. So that's the loading now. That's fine. So after loading, click on calculation at the top of your screen to run the calculations. And now we have to check the displacement due to the two loads on the structure. To do that, click on results at the top of your screen and then click on diagrams for members. So in this new window, you can see that we have 6 options here. You have the NTM, the deformation, the stresses, reaction, reinforcement, and parameters. Now, we'll not be going into details of all the options here. Let's just work with displacement today. Deformation today. Now, if you go to parameters, you can see some stuff here. Now, the description type, you can leave it at none, labels, or you if you want it's in text. Now, if you click that, open a new window tab, our results will be displayed on a new window. So click that and go back to deformation. Then click on nodal displacement to check the displacement of the nodes due to the two loads. Now here you can also do animation, but ignore that for now. Click on apply. Then as see, this is the deformation of the nodes due to the life load. So rotate it to view all sides and the structure. You can see that the original structure is still in place along with the deformation. Now change that to the dead load. Do not forget that the first dead load is the self weight of the structure, so there won't be any deformation due to it. So just try to view the sides